Good day, everyone. Glad to be here. Glad to be part of this awesome conference. Thank you for welcoming me for the first time. Just to quickly introduce myself. I've been working for several Linux distro. I've been part of the SysLinux project. I'm an FIO contributor part-time. And I'm also the founder of Kernel Recipes, if you have heard about it. It's a Linux kernel-oriented conference that takes place in Paris. If I'm in front of you today, it's for speaking about open firmware, obviously, but in a particular way. I'm working for Qtio, and we are not an hyperscaler, neither a CSP or an SMB. We are running 40K servers, x86 servers, and we are operating multi-vendors. And for operate this platform, we are pretty small. We were up to 3 pretty recently. And our task within this small team is to manage everything about the low-level stuff, including selecting the new platforms, testing the low-level performances, debugging the low-level issues, and also automate everything about monitoring faults and low-level configuration. So at Qtio, we did a big journey towards open source. A couple of years ago, we were just a fully proprietary infrastructure. We were running only Microsoft Windows. We were running proprietary switches. We decided to move to a containerized Linux infra. And also, we were part of the few which are actually operating Sonic in production. Sonic is a free operating system for network switches. We're running today almost 800 of them in production. We also moved away from F5 to Russia proxy to handle something like 9 million HTTPS transactions per second. So everything is fine. The infra is transitioning from proprietary to open source approach. And obviously, the next item is about firmware. And firmware is a daily pain. No one will hear you crying on your infra. You know the story, it's close to us, it's impossible to debug. And usually, it's also disconnected from the author. Someone wrote something, you execute it on your infra, but if it fails, what is your ability to contact him to say, hey, you made a fault. I'm experiencing this issue. How can I get it? And usually, this firmware are embedded by a company, integrated by a vendor that is selling you the hardware. So the ability to get back to the author is so difficult. And so we are experiencing daily issues on firmware on our infra. So as we did from switching from proprietary to open source, from Windows to Linux, we want also to get rid of the proprietary firmware to get to open source firmware to regain control, just to be sure that the hard software is under our control. And obviously, we want to operate them in a modern manner. CI/CD, version control. We want to manage our infra at most. So some could think, OK, so why are you coming to Open Compute? We are aligned with OCP vision, but we are running in colo. We are operating in 8 data centers, and we cannot enforce OCP racks in these locations. So what we decided is to, OK, we cannot get into OCP formats, but we want to get the taste of it. We want to keep the philosophy and to stay to open firmware. So let's try to get on OCP systems, regular systems, but running operating, running open firmware. So let's try to find a first target to achieve, and it's time to switch to OpenBMC. The BMC is one of the easiest we found. It integrates security, daily pain, so it's a good one. But our first thought was OpenBMC, it's not really made for us. We are too small. We are big enough, but we are at the same time so small. Who is operating OpenBMC today? Only the hyperscalers. So we felt being a part of it. We didn't felt it was made for us. But the second thought was, OK, but it's open source. We are used to do it. We are able to contribute, but should it be different? So let's try to investigate this path. But we can do it alone. We are too small to operate a full port of OpenBMC to our platforms. We need the hardware help, the hardware vendor help, sorry. So we went to see the OEMs. And most of the OEMs says, yes, we are investigating this. It's interesting, but we'll see. OK, thank you. And then we get to the ODMs. And for the ODMs, that's a total different story. Some said, you want open source? No way. It's AMI, and this is it. OK, thank you. The other one says, oh, wait, yes, we do it. OK, can I rebuild it? Can I sign it? No, you can't. OK, so what's the point? If you want me to run OpenBMC in this way, it's like looking a cake behind the window. I want to operate a full open source system. I don't want to get a fake open source project. I don't want to ask you the permission to update my BMC. I want to get, as for Linux, I don't ask you to set up my system. I want to be totally autonomous on my BMC side. So, money time. We are buying many servers. Not that much, but they are pretty high priced. So it makes a good amount of money. So we have been discussing this with our vendors when we decided to refresh some service types, the base compute nodes. And we said, if your product supports OpenBMC within a decent amount of time, so let's say a couple of years, you will have bonus point on our evaluation matrix. There is many items on the evaluation matrix, the price, the performance, supply chain, all this stuff, but open source is the one of those. And the only one that positively reacted to this was HPE. They said, OK, why not? Let's just try to make it. So they set up a team, a POC on Gen 10 Plus service, and we try to experience this. The point is the Gen 10 Plus systems were not designed to run a different firmware than the high-low. So if you can run OpenBMC on it, we have POC that works, but it exposes some part of the ASICs that taint it and prevent the motherboard, which is switched into OpenBMC, to be eligible to the RMA, being able to replace it if you have an issue, because you have exposed some keys of the ASIC. So by experiencing this with HPE, they decided to make some changes on the Gen 11. And because of the hardware change they made, it's not possible to delegate the signature to the customers. We co-presented this at OCP last year. And with Jean-Marie, we'll probably talk to you about it. And thanks to this evolution, Gen 11 is not able to run by default OpenBMC. And this is a major step for us. It's not possible to operate OpenBMC, open firmware, on regular systems. So now let's back to us. What makes us different? Why are we interested in open source firmware? What it makes a difference every day? First, we want to be in a position to update our firmware pretty often, like for Linux, build it, run it. But if you are considering BMC, you have to flash it. And if you are making a flash every single day on your BMC, you will be in trouble because of the endurance. So what we decided is to use the bootloader, because we are also able to manipulate the bootloader, to make just a network booting. This way, we can network boot the BMC, and so we are preventing the over-usage of the flash. Obviously, we keep a fallback locally if necessary. Our target, considering this open source firmware, is trying to get to the path of having a single kernel for all the systems we are operating. That would be my dream. A single source, then you make multiple builds for the OS, for the BMC, for the switches, and then your security assessment is much more easier because you know what you are running. So part of our expectation is to get the ASIC support being upstream. And this is the case for the HPE BMC, which is nice. If you look at the kernel itself, on the ODM side, it's 3.8.6.17. So you can try, and for the others, we don't know. It's even maybe not a Linux, but I'm not able to estimate the risk assessment. So switching to open source firmware for us would be an option to get much more control on what we are deploying on our service. We are able also to integrate what we want inside the BMC itself. Today, it's a LAN which is closed, and we want to put our own software into it. Today, we are polling the service to monitor. It's pretty painful and slow. We have many if vendor, if generation statement into our monitoring stacks, and it's horrible. So we want to flatten the differences between all the vendors. Yes, Redfish was supposed to do so, but it doesn't. By the end, you have endpoints which are specific to any kind of flavors, which is painful. So we want just to integrate our monitoring stack or any kind of binary inside our BMC. We are even considering, it's pretty exploratory, if we can run software inside the BMC, could the BMC be in a position to open an RMA to the vendor if there is an API for it? And so the system is totally autonomous. I detect a broken DIMM, I'm just opening an RMA to the vendor. It's under debate, but it opens doors. Other real stories. When you get a proprietary BMC or a proprietary firmware, it takes so long to get a fix. On all the systems I've been working on, it rarely takes less than 18 months to get a fix. So I've put here some examples, and we are lucky because we are voiced on our vendors, but it's so difficult. Typically on an ILO5 firmware, if you look at the temperature, it's not a temperature. It's a gauge. It's said to be Celsius, it's not Celsius. It's crazy. If you look at the CPU temp, if you know a little bit about it, the CPU temp, you take the max temp from the processor, you remove the DTS, which is provided by the processor, and you get the temperature. In fact, it's implemented like the min of 70 minus the DTS. And so all the CPU temp is reported at 40 at any time, unless you are above the distance between 70 and, well, it's a nightmare. It doesn't mean anything by the end. So we complain about that. We get a fix. It's implemented since the ILO on BIOS 242. And now you have a new entry, which is called CPU1 PKG temp, that reports the real temperature. But it took 18 months to get this. It's crazy. If you look at the BIOS also, there is no way to protect the BIOS itself using the BMC watchdog. It's possible on many vendors. On HP, it was not possible. We asked for it. It took 18 months. It's so long to get a feature. I can understand why, but when you are experiencing an issue, it's really long because you have to keep in mind that the service are operating for 5 years. If you take half of this time to get a fix, it's difficult to operate them. Some other example, we get issues with the red controllers. Since we moved to the kernel 5.0, we have experienced some hangs, and it took nearly a year before the vendor, so not HP because it's delegated to someone else, was able to understand what we are experiencing in production. So they were able, after 1 year, to reproduce the bug. And the first statement was, OK, but we are running the Linux kernel 5.0, and no one uses this. What? I do. The 5.2 is out. I'm using it on production. It's fine. So we have to push them all the time. And once they get a fix, after 18 months also, I say, OK, fine, thank you. Did you try it with IO ring? IO what? OK, give it away. I mean, they are not open source minded. They're just working by facing walls. They are never anticipated what open source is able to provide, consider the performance, the usage. And so we are the first one to experience it in production. So for 18 months, I had the choice between having some crashes in production or running a 4.x kernel. What's the best one? I don't know. About the open source firmware, there is, I've been bitching a bit on HP, but I can tell AMI is much worse. So they are shipped with non-root password. They are leaking they are leaking, sorry, the credential into the logs. I've been asking many things to them, and every time there is an answer, you just want to cry. I mean, so by the end, we have, I think it took also something like 18 months or 2 years to get a BMC which is almost acceptable. I mean, it doesn't crash, I can operate it, I can just SSH, there is no default root password. But come on, it's 2 years for that, I just want to throw it away. So anyway, you know the pain. So why do we want also to get into the open source model? We are experienced engineers. We know how to operate systems. Most of the issues we saw, and we had the feeling, so every time we saw the bug, we can fix in days, not in months or years. And we see the vendors are, even the trusters, they don't open doors for us to help them at fixing bugs. Even for the most complex bugs, I'm not saying that I can fix any single bug. It's totally untrue. But I can recode. I can try some code paths. I can make some print-care debugging. I don't know, anything fancy. But I can. I'm owning more servers than the developer, so I can produce bugs. I can repeat them. I can prove what's wrong. So even if I'm not in a position to fix the bug, I can help the vendor to understand the bug. So open source for this is very nice because I can rebuild myself, I can do anything with it and prove what's wrong and test all the conditions or anything that help to make the debugging being successful. So I would love to be in a position not only to wait, but being active, being able to contribute patches, IDs, traces, anything. But we are not allowed to that. So usually what we see from the vendors is there is a pushback. They don't want us to help them into this area. And we would love to see them transitioning to a position where we can collaborate on the firmware operation and debugging. Another impact of the open source firmware is the longevity. It's not obvious at the first sight, but if you are able to maintain your hardware, if you are able to maintain your software, so typically Linux, if you are able to maintain your firmware, then you can extend your warranty. Today I'm buying servers which have 5 years of warranty. We are considering bumping to 7. But what is the meaning of bumping to 7 if I'm not in position to update them? Just an example, I have an issue on a system which is not able to service interrupt 13, the one to read the block device when the system is booting up. But the system was end of sale in 2018. What is my chance to get a serious debug and a fix in a decent time and before the end of life of the product? It's almost 0. So what we would love by switching to open source model is to gain what we have and to mimic what we are doing with Linux. On Linux, the i386 support was dropped only in 2012. It was 5 years after the end of life of the product itself. But it was because of some technical difficulties of maintaining this architecture. But if you consider the i46, there is still some patches going to the Linux kernel mailing list, even on the 5.14, 15. It's crazy. You can operate Linux on systems which are 30 years old. So we would love to be in the same position just to decide if my BMC is able to run the software I want to hit for years, not only for 3 years, 5 years, maybe more. And this approach of being able to support a longer time our service is very interesting because when you consider the amount of power, of computing power we have in service today, having them for 5 years is a bit short. We can extend this warranty, but at the condition of being able to get a strong support. And open source is a great helper to open doors for these greater life cycles. And so the best server is the one we are not producing. If we are able to extend the lifetime of the service, then we will buy less servers, or the one we'll buy will last longer, And so we'll avoid to produce, sorry, I don't find the English word, wastes. We are trying, by running the infra, to be kind of careful about the ecology and all this stuff, not trying to produce unnecessary CO2 and all this stuff. So being able to increase the warranty is also a way, or the usage of platform is also a way to avoid creating wastes. My call for action around that is ask your open source vendor, hardware vendor to do open source. We did it. We had the chance it worked. But the more we are asking for this, the more chance we have to get it done. And honestly, HP was one of those, and I'm just amazed they did it so fast. We are now able to buy Gen 11 servers running OpenBMC. And to me, it's a world premiere. They did it right. It's upstreamed. It's just diversity. We are able to run HP servers on ILO or OpenBMC. It's your choice. And this is a great benefit for us. And our position at Criteo is saying that if a vendor is doing something right, you have to support it by buying servers. We have, by the money we are spending in servers, the power to help the market to go in the right direction. I'm an open source activist for 20 years. I will continue in this direction. I want the servers to be much more open source than they were before. And thanks for HP for doing so. But please, also, if you are buying servers, if you are trying to join our efforts to express our needs to the vendors, feel free to ping us. The more we have to ask the vendors, the more chance we have to get open source infrastructure. This is it for me. So if you want to contact me, I'm Erwan Velo on Twitter. I'm also co-maintaining the Criteo Infra account. You have my emails. I'm also on OFTC. Yes, I'm old, and probably many of you are also on IRC. So if you have any question, I'm available. Okay.
Thank you. Thanks, Erwan. I gotta apologize. I throw you a little bit into the cold water, right, by pulling the talk in 10 minutes. Sorry for that. Yeah, if anyone has questions, raise a hand, and I will come by and give you a microphone. Oh, yeah. Oh, yeah, or Max can come by.
It's very exciting to see commodity hardware with OpenBMC and custom firmware on it. Does this have any implications for the x86 firmware on these platforms, or is this solely on the BMC side?
Today we are only running on the BMC side on Open Firmware. We'll let Jean-Marie maybe explain as a roadmap if it's a question about how many firmware will be open, because I cannot speak for them. But what I can say is at least the first one they open is the BMC. It has been worldwide announced as available, so any customer, and it's also a big question I had is, okay, they're opening the BMC, but what is the entry point, the entry ticket to get it? And by the end, it's free. Anyone can get it. It's not if you are big ones, you are allowed to get BMCs, Open BMC. Anyone, it seems that any kind of customer can experience it. So it's also part of my personal, I don't know if I'm saying English word, sorry. I'm happy about this situation because our co-working with HPE has a final impact on all the customers. Anyone can now experience OpenBMC. So we didn't did it alone, obviously, but I'm proud to be part of this energy, trying to ask them to be open to the world.
Hi, Gabriel. Thanks a lot for the presentation. How big is your team of engineers doing firmware dev and or ops? And do they do only BMC firmware related things? How did you train them, ramp them up?
So today the hardware team is 7 people. and the people dedicated to the firmware is almost zero. I'm totally honest on this. We are spending part-time of it. It's not yet on production. We did the POC with HPE, so we have spent a part-time engineer on it, but never spent a full-time on it, because when you are small, you have also daily issues to maintain. As I said, we have to, it's sad, but we have to spend much more time on fixing buggy closed source firmware than spending time on debugging, on improving open source firmware. So we are still split. And so we are trying right now to improve this part, this team, to work on these topics. So we will probably a part-time of firmware engineer, not a full-time. We don't have the resource for this. And thanks also because it's upstream. So it will be much more easier for us to integrate these changes, because they will not sell us an product. We just have to integrate it into our CI and to rebuild downstream to make our own firmware. So today, I would say I have a part-time engineer should be enough to maintain this topic.
Okay, we got another. You still have a question? Yeah, Jonathan first.
Yeah.
I'm here. I will come to you afterwards.
Sorry. So this is Jonathan from Meta. I'm also the open system firmware lead of Open Compute project.
Mm-hmm.
So I know that you do not operate OCP server, because OCP server, the dimension is different. Right?
Yes.
Right. But we do have firmware projects in OCP as well. So what would motivate you to join the OCP for not hardware related thing? You can join the software related projects.
Yeah, mostly.
Like OSF.
Yeah, the open source, the software side of things is very interesting. This is what we are considering to be part of, because this is for us the only attainable target we can get. We cannot get the hardware side of things, so we only concentrate on the software side of things. So yes, we'll be very inspired by OCP, and we'll continue on this path. Yeah, for sure.
Hi, I'm Elias. At some point, you mentioned signatures and signing of the binaries that you load on the BMC. So how does that exactly work? Do you need a private key from the ODM that will sign your initial binary?
So for the ODM, there is no options to make it. The only way that will exist is the one with HPE. So the question is, the services are delivered running ILO, and then we have to transition them to OpenBMC. So there is a protocol to follow to be able to engage our own keys, but they integrated a specific chip to manage this. And so one of the interesting parts is we are about to get it back and forth between HPE and the client. So we can get the HPE system, enabled system, and to install our own keys on it to be able to install OpenBMC, and it's reversible. Then HPE can get back the systems to their own keys, and we are not exposing our own keys to each other. So we are, and that was part of the work that have been done between the POC on Gen 10 Plus and the Gen 11. They have been able to get in a, because Gen 10 Plus was designed to get a single owner, which was HPE. So installing someone else was an issue. So this is why they made a hardware change for this. And since we just have to synchronize on the way to enable our systems to get our keys on it, and when it's done, we are owning the root of trust.
You
and
basically have the private key to sign.
And so it's up to us to have our own signature toolchain on all this stuff, the CI, on all this stuff to get down the software we are booting on the BMC.
Thanks.
Hi, I really like your NetBoot idea for the BMC, and so I had kind of a three-part question. Which protocol are you using to boot them? How many would you say would boot at a time? Because you're doing a neat experiment here on a, like as you point out, a scale that ODMs can't do. And then the final one is, how reliable has that been in practice?
Today, honestly, it's only a POC. It has been done for a couple of systems. So I think it's a TFTP lame TFTP booting. Yeah, I think so. And if you want to turn it into production, we will have to go into HTTP to get the scale. And probably other techniques also to avoid having a strong income of requests when we are rebooting a huge amount of nodes. So I think we will have to integrate a kind of timer to, if we are just power cycle all the systems at some time, we have to integrate a random sleep to avoid that all the systems are trying to boot at the same time. unless we would have a too strong incoming of requests. This kind of techniques, honestly, today we are still on the POC side. We tried it works. But if we have to get into the industrial mode, then we have to define these little tricks to ensure that we can quickly boot the infra.
Okay, so I just remembered something I thought I'd mention. At Los Alamos, we built a thing called BeoBoot, B-E-O-B-O-O-T. It's on GitHub now because I put it up there. And it was scalable booting for network. And the way it works is, as nodes boot, they actually become temporary boot servers for other nodes.
Yeah.
And so we were able to boot 1,000 machines in the time it took to boot 32 because it was kind of a square root thing.
Okay, I will.
Yeah.
We'll
If you want to just take a look at that, let me know.
Yeah.
But it's all there.
Thank you.
Yeah.
Honestly, just to be clear on this, we are not envisioning being on production at scale before next year or something like that. We are still on the POC side. And we were waiting the enabler of having a default product, which is already OpenBMC enabled. And so it's Gen 11, and Gen 11 is not yet on the market. It's just incoming. So we will still have to find this adjustment when turning into production. So we are still in between the two because we cannot really turn the Gen 10 Plus into production because of the array missing and all this stuff. So we didn't yet experience the scale, just to be honest. But it's a goal.
Any more questions? Then
I have a follow-up question on the key provisioning. Is there any way for the BMC to attest what firmware it's running, or can you talk a little bit about what the sort of secure or verified boot system is on the BMC?
I will not be the right one to speak about it. I'm sorry, I don't have enough experience. Maybe Jean-Marie is able to do so, but I'm not. I think one of the issues we have today is we don't even have all the key signing infrastructure at Criteo. We are working on it to get something which is strong because we didn't hide it properly. So the first step is to build a strong signature system. And then the right connection with the BMC booting, I don't have the technical details. So I'm sorry, I'm not able to speak about it. Sorry.
Okay. More questions? Doesn't look like it. Oh, yeah.
Hey, I'm Jan. I have a question about testing of this firmware, right? So if you have a release cycle of 18 months, it's not that critical, right? But if you want to release your firmware with a shorter cadence, then you need to think about quality assurance of this, right? Testing, testing new releases. How do you plan to do this?
Usually in the CI, you can implement some. We can boot some. This is what have been done by Jean-Marie, which is very interesting. We can boot systems on the testing BMC. They've been in position to instrument physical servers to boot some not flashed BMCs, and so you can make a physical test on a real server running the BMC inside the CI. And so if the CI, then it's up to the amount of testing you are doing on it. But if you are to boot a real server running a BMC, then you know how good is it, depending on your patch. So it will be a mix between unit testing and booting the image that have been passed to CI onto a real server to ensure that it works.
Okay.
Thank you all. Thank you for attending, and thank you for welcoming me to this.
Thank you. And sorry again. Thanks.